We've been making generally very simple sounds with very short expressions, typically a unit generator and some envelope to multiply it by, maybe a few more details like a little vibrato, but whatever we need to illustrate some concept. We have not actually been focused on building realistic, rich, complex, beautiful musical tones. And so now what I would like to do is just emphasize the importance of uh, thinking about every aspect of a sound and controlling it with control functions, with filters, with vibrato and other techniques to achieve some level of complexity that's truly interesting and musical. One technique to think about always is making smooth transitions. Um, if you should never abruptly turn an oscillator on or off because it clicks and leaves obvious artifacts. So we've learned about using envelopes to smooth sounds, the output of oscillators and other unit generators. But what about things like vibrato? You know, if you turn vibrato on instantaneously and leave it at full vibrato depth to the end of a tone, that also sounds rather abrupt and unnatural and can be very mechanical. So what I'd like to do is go through some examples using Nyquist of starting with a very simple sound and iteratively adding more and more control and thinking about more and more aspects of the sound and making it a little bit richer. We will start with a very simple FM oscillator and an LFO to provide vibrato. So what's wrong with this? Just about everything. It started abruptly, the vibrato starts abruptly. Let's start there. So we're going to make a smooth vibrato function, which is that same LFO we use for vibrato, 6 hertz, but we are going to multiply it by an envelope so the vibrato doesn't start instantaneously. Let's listen to that. So you can hear that the vibrato is increasing in intensity over the first half of the sound. And of course, we need to multiply this whole thing by an envelope. So I've made a function envelope tone where we just multiply by an envelope. Okay, so now at least the vibrato and the overall shape of the note are beginning to sound a little bit reasonable. However, it's a sine tone. You know, sine tones are in Nyquist. They're easy to make, and they're intended to be building blocks for richer sounds. You don't really want to listen to too many sinusoids, I think, as if they are musical tones. So what I've done is I've built a wavetable, and I've modified the code to incorporate this wavetable called mytable into the FM oscillator. And here we go. By the way, this is code6.sal, and you can download it and study this. I'm trying to go through it quickly because I know it can be boring to be led through code, so I just want to hit the highlights. The next thing we're going to do, because that sound that we heard I think was pretty harsh. That was a bright spectrum, and to turn a note on with full brightness at the very beginning of the tone gives this kind of harsh mechanical sound. So now we're going to add a filter. This is a low-pass filter which removes high frequencies, and the cutoff at which high frequencies, the frequency at which we pass sounds below that is controlled by an envelope. And so here we start the envelope at 100 hertz, and in half a second we ramp up to 10,000 hertz. This is not a complete, it does not completely remove all higher frequencies, but it attenuates them. And so here we go. Okay, so now it's still bright. You might think it's still a little harsh, but at least it kind of unfolds in a slightly more musical way. All right, so let's leave things there and go back to our slides. The next thing I want to point out is that you can compose control functions and combine control functions. So there's just because you use LFO for vibrato doesn't mean you can't add something to that or multiply that by an envelope. And so it's very useful to make combinations of LFO for periodic variation with PWL, which is kind of controlled long-term variation, and noise, which adds randomness and jitter to something that otherwise would sound very mechanical. So we're going to go back to Nyquist and look at an example that's using noise. So here's a very important trick with noise. The noise unit generator, shown right here, normally computes at the audio sample rate. So it's very high frequency noise. It's not really appropriate for controlling vibrato, for example. However, the trick is that we don't have to synthesize noise at the sample rate. We can specify the sample rate, and we do that with this function called sound srate abs. It's a special function. It's not a normal function. It actually modifies the environment, just like stretch and shift. It modifies the environment so that audio rate unit generators like noise are computed at a different sample rate. And here we've specified a sample rate of 10. So that means at only 10 hertz, every 10th of a second, we generate a new random sample. And then when this signal, low sample rate signal, is combined with higher sample rate signals, Nyquist will linearly interpolate between those random samples. So that gives us something like a piecewise linear function. It is actually a piecewise linear function, but it's automatically generated with random amplitude samples regularly spaced at 10 hertz or whatever frequency we give it. So I want to put in a fairly large frequency deviation here, and now we're going to play, let's see, the sound with smooth vibrato made by this function, where the vibrato is the addition, the sum of this random fluctuation plus this LFO vibrato function. Okay, that is a little bit excessive. You know, to me it sounds almost sickly instead of interesting, but let's turn the amplitude down from 1 to, let's say 0.3 and redefine this function, and let's see what happens now. Okay, so that's getting in the neighborhood of acceptable. There's a little bit of vibrato, there's a little bit of randomness there, and it's certainly less mechanical sounding than what we had before. So the point of all this is that you can use many control functions combining randomness, LFO, and noise in overall envelopes like PWL to build very interesting control functions. And you can apply those interesting control functions to many different parameters, to low-pass filters, to vibrato, to the overall amplitude envelope of a sound. And by doing all of these things, you can make sounds much more rich and interesting.